Okay, question number 3. Question number 3 looks like a regression question, but I'm going to just go through and check. It's actually a question to do with the PMCC. We're told that 14 candidates sit 2 test papers, paper 1 and paper 2, on the same day, and their marks out of a total of 50 achieved are in the table. We've got mark on paper 1 and mark on paper 2. We're asked to calculate the value of the PMCC, R, between the marks on paper 1 and those on paper 2. Again, you're going to be divided on this as to whether or not you use the old calculator or the new calculator. I tend to favour using the older calculator, but again what I need to do here is to enter my data. There are 3 marks available for this question, and again all of the work essentially is going to be on the calculator, so I need to be really sure that I enter these values carefully. I've gone to mode and to the stat function, and I'm going to check or to click on number 2, which is a plus bx, and I'm now given an x column and a y column to enter information, and very carefully I'm going to go through and enter all the x's, and then I'm going to add the paired data, the y values, to that. So 36, 29, 33, 17, 42, 26, 45, 12, 25, 19, 26, 15, 28 and 11. And that concludes the X's. Again, this is really a question where I'm tempted on the video to try and rush because I don't want you to watch a long time me putting these in, but really take care when you're doing this in the exam. 46, 18, 34, I'm entering the corresponding values of y, 24, 45, 21, 37, 15, 35, 17, 38, 11, 44 and 21. Well, at least my x and y values match up here, and I've got the same number of x's as I have y's. And again, I would really suggest in the exam that you go back through and just check that data one more time. Because it's 3 marks, you're looking at about 3 minutes to do this question, but just enter them very carefully. I now clear that screen, and for anybody who's had me, they'll know that we're going to ask our old friend Reg to help us now. So we go Shift, Stat, we'll find Reg at number 5, and the value that we're after is number 3, which is R, the PMCC. I press that and I get 0.748. So again, as I said, double underline, that's my answer, but all of my working was done on the calculator, so it's really 3 marks or no marks. You've got to be very careful. For part number 2, I'm asked to interpret that value in the context of the question. Well, 0.748, the key words that they're going to be looking for in the mark scheme here, positive and correlation. In terms of the strength here, you might well feel that you'd like to put a measure as to the strength. So you might put that it's quite strong. I don't think it's very strong, but I think there's quite strong evidence that we do have positive correlation. But the key bit here is that they ask in the context of the question, so I've not finished now. What I need to say is it's positive correlation, which is quite strong, which shows that students who perform well on paper 1 tend to do well on paper 2 as well. So as the x variable goes up, the y variable goes up. Don't just write here positive correlation between paper 1 and paper 2, which is a very common answer that I see. Do make sure that you're actually saying as x goes up, so y goes up, and I've done that with reference to the papers. Okay, I'm now going to move on to part B. Part B is based on more information that's given below, and this information is given in statistical form in terms of statistics that I've got from other samples. It was then discovered that 7 of the candidates, another group T, had been given extra tuition in preparation for the test, whereas the other 7 candidates, group U, had only been given the usual tuition. The summarised data for the two groups are as follows. So we've got Group T and Group U. So for Group T, we've actually already been given their PMCC. I suspect, as is confirmed down here, that what we're going to be asked to do is to calculate the value of R for Group U. Well, happy days on this one, because most of us, if you've been using your calculator as we've done in the first part, will also have been shown that there's a formula for calculating the PMCC. I'm going to go back into the formula book here. I'm not going to chance it by trying to memorise the formula, but I'm going to find it. So we go through all the pure maths, and sure enough we find our statistical work here. And as we look through, here is our formula. It's on page 13 for the PMCC. So we've got R is equal to SXY, and we're going to divide that by the square root of SXX multiplied by SYY. Sure enough, I've got those statistics values. So for Group U, so I'll put a U here, the SXY value is 34.57, and I'm going to divide that by the square root of SXX, which is 279.71, and I'm going to multiply that by SYY, which is 112.86. Now at that stage I'm going to be starting to get method marks. For simply stating the formula you wouldn't. I now need to go through and to calculate that value, and again you will have your own ways of doing this. Some of you might use the fraction function, so I'm going to use brackets on this one and just ensure that I get this right. So square root outside the brackets and then inside the brackets 279.71, just taking care to make sure I get these right, multiplied by 112.86, and close the brackets, and I need to delete that one and close the brackets, and my answer is 0.195 to three significant figures, and I'm going to double underline that one because that's my answer at that stage. What I'm then asked to do is to interpret in the context of the question the value of R for each group of candidates. So we've got two groups here. I've got for Group T a value which is actually given to me of 0.261, but I'm just going to put that down so I've got that clear in my mind, and I've just calculated for Group U that R is equal to 0.195. Now I would suggest that there are 2 marks here, that both values are similar and only show weak positive correlation. Now, what we've actually got here are the 2 values for, so it's been, I'm just checking on the context. 7 of the candidates Group T had been given extra tuition, and 7 of the candidates didn't have extra tuition. The summarised data for the 2 groups are as follows, and we've got those 2 groups there. So what we've actually got, both values are similar and only show weak positive correlation between their scores on the 2 papers. Question number 3 asks us to comment with justification on the apparent effect of the extra tuition, and is worth 2 marks. Having worked out previously that the PMCC for Group T and for Group U were both very low, this would suggest that the tuition must be having some sort of effect, because in part 2 of the question, part A, we were asked to interpret our PMCC for all of the candidates as a whole. When we consider all the candidates as a whole, the PMCC is actually quite high. I would suspect the diagram looks as below. This is further evidenced by the fact that if we look back at the original data, the mean for the group that's had the tuition is very much higher than the mean for the group who didn't have the tuition. So, the impact of the tuition appears to be significant, because as the PMCC for the two groups is actually low, it means that when we put the data together, we're probably getting a diagram that looks as the one below.